Hello and welcome to my video on quadratic equations, and in particular we're looking at factorization. So I'm looking at a general principle for factorizing quadratic equations of the form ax squared plus bx plus c. So the way I was taught it, the way I've always understood it, is we need to find two numbers, let's call them d and e, where their product is equal to ac and their sum is equal to b. So they multiply together to give AC and they add together to give b. So these are our two conditions, if you like, and they both have to be satisfied in order to proceed, in order to factorize it. If one of them fails, then the game's over. Okay, so I've written them down. So just to summarize, so conditions d plus e must equal b and de must equal ac. Okay, we will look at a specific example in a moment, but let's just look at the general case. So the general case is ax squared plus bx plus c. So one condition is that b is equal to the sum of the two numbers. We need to find two numbers that add up to give b. So we call them d and e. So let's substitute that in. So that becomes ax squared plus d plus e times x plus c. So we replace b by d plus e. So that's our addition condition satisfied, if you like. Okay. So then we can rewrite that as ax squared plus dx plus ex plus c. And then we can start factorizing that a little bit. So we take an x out, we get x times ax plus d plus ex plus c. Looks a little bit messy because we've got a's, we've got d's, we've got e's, we've got x's, c's. We've got quite a lot going on there. Right. But now we can use our second condition or assumption, which is that de, the product of these two numbers, must be equal to ac. We already know that the sum is equal to b, and now we're going to use the second condition that the product will be ac. So we're going to replace d by ac over e. So where did that come from? Well, de is equal to ac, so d is equal to ac over e. Plug that in. And that's good because that has now introduced an a, which we can take out because a is appearing on two terms inside the bracket. We've got ax and we've got ac over e, so we can take the a out. So we get ax, and then in the bracket we get x plus c over e. And then the second part, ax plus c, we can write as e times x plus c over e. So e times x is ex and e times c over e is c. And then we now have a common factor of x plus c over e. We can take that out and put it all together. We get ax plus e times x plus c over e. And then the roots, if we're asked to find the roots, they're just minus e over a and minus c over e. Okay, but that is the actual factorization there. Ax plus e times x plus c over e. Okay, but it's in terms of e. But e involves b and d and, or a, c and d, But anyway, that's it done, okay? And that works because we have satisfied both conditions. We've satisfied the product condition d equals ac and d plus e equals b is the addition condition. We've satisfied both. The addition condition we assumed up here, we plugged it in up here. The product condition we assumed here, we plugged it in down here. We changed d to ac over e. And it all comes out to be that. Now, one thing I want you to pick up on here is that a is appearing in one of these factors, but it's only appearing in one of them. As you would expect, you wouldn't expect it to appear in both of them because then you would have an a squared. Now, if a was 1, if that equation was x squared plus bx plus c, or you know, if you were given an example and a was 1 in the example, then that just collapses down to x plus e times x plus c over e. So when a is 1, life is a lot easier. But in general, a won't be 1. And this is the general solution. Okay, now we're going to look at an example to show this in work. So 2x squared minus 5x plus 3. So what's a? So a is 2, b is minus 5, c is 3. So we need two numbers that multiply together to give 6. And we need two numbers that add together to give minus 5. So they will be, so that means D and E obviously, so they will be minus 2 and minus 3. Minus 2 minus 3 is minus 5, and minus 2 times minus 3 is 6. Right. And then let's start factorising this. So we get 2x squared minus 2x minus 3x plus 3, 2x, x minus 1, 2x minus 3, so that's factorised. And again, you'll notice that a is appearing here in one of the factors, but it's not appearing in the other. So a is 2, obviously. So that appears in one of them, but not the other. And then you'll notice that this minus 3 here is equivalent to e. And this minus 1 is equivalent to c over e. So if we go back to this form here, ax plus e times x plus c over e. So ax is just 2x obviously, e is minus 3, x is x, and then c over e is minus 1. Let's just verify that, c over e, so c is 3, e is minus 3, 3 over minus 3 is minus 1. Okay, so even if you memorize that formula, you can write down the factorisation very quickly. So let's suppose some other example. Just forget those numbers for a minute. Let's suppose I had another example and I had D and E equal to 2 and 3. So they multiply together to give 6 and they add together to give 5. So B would be 5 and AC would be 6. Whatever the example would be. Doesn't matter what the numbers are, but as long as AC was 6 and B was 5, right? So then D and E are 2 and 3, okay? Now I can pick E to be any one of those. I can pick E to be 2 or E to be 3. Let's just pick it to be 2 this time, okay? Just to be awkward. So then whatever that example was, whatever that quadratic equation is, that could be anything. That could be ax squared, but it's going to be plus 5x because B is 5. And then it's going to be plus C. We don't know what AC is, as long as AC is equal to 6. So AC could in theory be, it could be like, A could be 1, C could be 6. A could be 2, C could be 3, etc. But as long as they multiply up to get 6, okay? Now, so that would be the equation. And then just make AC equal to 6. Doesn't really matter. Okay, B is obviously 5. We can't really change that. Right, so anyway, so I'm going to pick D to be 2. So if I factorise all that out, doesn't matter what A is or what C is. If I factorise it all out, I'm going to get down to this. So my answer would be AX plus E times X plus C over E. So we know A, or sorry, we don't know A, but just leave A as it is. So that'll be AX. So I'm going to pick E to be 2. So it'll be AX plus 2 upon X plus C over 2. So whatever A is, just plug it in there, and whatever C is, just plug it in there. Equally, I could have chosen E to be 3. If I choose E to be 3, it'll be AX plus 3 times X plus C over 3. Okay, It's entirely up to you. That's the beauty of it. Okay. So thanks for watching the video, guys. I'll see you on the next video. So please like, share, and subscribe.